In this video, we're going to talk about topic 16b, adding and subtracting rational expressions. So the first thing we want to start with when we add or subtract rational expressions is looking for that least common denominator. In problem number 1, our LCD is going to depend on these factored versions of the denominators. So first let's look at the first left denominator. We have 2m minus 6. If I factor out the GCF of 2, I'm left with m minus 3. The second one, 2m, can't be factored, but we want to think about the fact that the 2 is already there. 2 is a factor that they both share, so we don't need to put that twice. The m is its lone factor from the second piece, and then m minus 3 is another factor. So those are two separate pieces, the m and the m minus 3, because factors are multiplied, so we can't have that minus 3 and consider it just one factor. From here, we want to multiply by the missing piece. So in the first one, the thing we're missing is that second m. And in the second one, the thing we're missing is the m minus 3. So we do it in the top and bottom. And then we're going to distribute in the numerator. So we'll get m squared minus 6m. And in the denominator, we have 2m times m minus 3. In the right one, I'll distribute that 5. We get 5m minus 15 over 2m times m minus 3. Next, we want to combine our numerators. So I've got m squared minus m when I combine these like terms, minus 15, all over 2m times m minus 3. And the last step would be to try to factor the numerator just to see if anything could maybe cancel out. So I'm looking for something that can multiply to be negative 15 and add to be negative 1. And I don't think anything's going to do that because 15 is 5 and 3. Those don't have a difference of 1. So this is our final answer right here. Problem 2, we're going to start in the same way, thinking about our least common denominator. But in this case, we really just have one fraction, and the other one is just over 1. So the LCD is going to be whatever that one denominator is. So 4x plus 4, and you could call that 4 times x plus 1 if you wanted to factor it, but it doesn't really change how we do this. So the right fraction is missing that 4x plus 4 entirely. So we're going to multiply at top and bottom. And my first fraction doesn't need anything because it already has that denominator. Now, the tricky thing about this is that when I'm distributing this 5x, it's a negative 5x. So we need to think about distributing negative values to both of those pieces here. All over 4x plus 4. And now you can almost think about like we're adding these two fractions once we distribute that negative. So I have x minus 4 on top left. I've got this piece on the top right. So we're going to combine like terms. The x squared term, there's only the 1, the negative 20x squared. We've got a positive x and a negative 20x. Makes negative 19x. Then a minus 4. All over 4x plus 4. And that's it. Now these next couple of problems give you the answers already. So what I want you to do is pause the video for a second and try problem number 3. And you can see my steps as we go. I'll sort of give you a second in between each step and talk about it. First step is to find the least common denominator in problem number 3. And then multiply by the missing piece. So in this case, it's literally just the opposite denominator. And then we're going to distribute. Now we combine the numerators together, and you can leave the denominators factored the whole time. You never need to multiply that out. And there we go. Got the same answer as the box. Let's try number 4 now. So you can pause it for a second, find your least common denominator. So in this one we actually have to factor the bottom left denominator, and we can see that the 3 is already a common factor, but the n and the 3n minus 5 are not. Then we multiply by the missing piece. Combine our numerators, and that's our problem. These next ones are extra tricky, but remember, we want to treat it as if it's like two problems in one. The bottom is an adding problem, and then once we combine those into one fraction, we'll keep change flip and do the top divided by the bottom. So let's start by adding that bottom set of fractions. Luckily, we already have a common denominator here. So I'm just going to keep the x on top for now, all divided by, we got x plus x squared over 4, because these already had a common denominator, so that's good there. Now, because it's just one fraction in the bottom, we want to keep change flip. The first fraction is that x that's just sitting on top. Keep that as it is. And if you want to see it as a fraction, it's just x over 1. We change it to multiplication, and we flip the blue fraction to being x plus x squared on the bottom, the 4 on top. Now we multiply straight across. So 4 times x, and we usually just put the numbers first, so it could be 4x. And then 1 times anything is just that. Now, the issue with this is it doesn't quite match our answer. So what that means is that something can simplify away. Before you just start canceling stuff willy-nilly, think about canceling has to happen when you have factors. So in the top, 4x can't be factored, but the bottom has that greatest common factor of x. And if I pull out an x, then I'm left with 1 plus x. Because we're dividing x by x, we get 1. We divide x squared by x, we get x. And now I'm allowed to cancel out this x and this x. So we get 4 over 1 plus x. And now it matches our problem. This last one's tricky. First, just look at that overall top fraction, treat it like an addition problem, then keep change flip. So pause the video and give this one a shot right now. So first I found my LCD for just the numerators in that blue rectangle right there. It's going to be 4 times x minus 1. So we multiply by the missing pieces. So let's do that distribution. Remember, when I'm multiplying binomials like this, you want to keep them in parentheses, do all that distribution. So we get x squared minus x plus 1 over 4 times x minus 1 plus 16 over 4 times x minus 1. All over that big 16 in the bottom there. Now we can combine the numerators together because we have that common denominator. Then we keep change flip. So we keep this first fraction, change it to multiplication, and flip 16 into 1 over 16. Then we multiply straight across. And this is what we get as our final answer, which, if you're upset about that not matching, let's really think about that. 64 could distribute into the denominator, and we'll get 64x minus 64. So this is our final answer.